In this video, you're going to practice solving systems of equations using elimination. So we've solved systems of equations by graphing, we've solved systems of equations by substitution, and now this is the third method, elimination. Elimination means that you're going to eliminate one of the variables. And the equations are going to be nice and set out for you to where you don't have to manipulate it. You just have to figure out which one of the variables will cancel, either the x's or the y's, based on the way the equation's set up. So what I like to do is I look at the problem and I rewrite the entire problem. If I write over the original problem and I make a mistake, I can't see what the original problem really was, even if you do erase good enough. So that's always my helpful hint right there. So I'm going to rewrite both of the equations and set them up stacking each other. Like in elementary, you would stack your numbers to either add or subtract. So that's what we're going to keep on doing with our two equations. We're going to keep them stacked, one on top of the other, one right below the other, and you're going to add them together and let's see what happens. So when you look at the two equations, you're going to try and figure out which variable is going to cancel. Just by looking at this, 3y plus x equals 19 and y minus x equals 17. Without looking at this plus sign, ignore the plus sign just right now. I want to recognize that my x's are going to cancel. And so when my x's cancel, all I have to do is combine the y's and combine the constants and then solve for y. So if I look at this, 1x, one's positive, one's negative, you want to recognize, that the x's are going to cancel. So right here, your x's are going to go away, and you want one of them to cancel out. From here, all we have to do is add whatever is left over straight down. So if I have 3y plus 1y, I'm going to get 4y. If I have 19 plus 17, I'm going to get 36. From here, it's just like all the other equations. Solve for y. Divide by 4 on both sides, so y is going to equal 9. And again, just like substitution, we're not done. Once you find one of the variables, your second step is to always take that variable and that value and plug it back in to find the other one. So now we're going to take y equals 9, and we're going to go to our next step and plug that in. So we're going to plug in 9 for y. You can use either equation. It's your choice. I'm going to show you both of the equations. You're going to get the same exact answer. Here, there's not one that's easier than the other. There might be for you if you like to deal with positive values and you don't like dealing with negatives. Either equation is okay to use. So if we use y minus x equals 7, and we're going to plug in a 9 for y, it's going to be 9 minus x equals 17. So I said 7 earlier, 17. So here, if I want to solve for x, I need to move that 9 over to the other side. The only way you can move that 9 over is by using subtraction. So you're going to subtract 9 from both sides, and then you're going to get negative x equals 8. You can't say, okay, x is 8, y is 9, that's my answer. No, you cannot leave a negative 1 in front of the x. You're not done solving. So your last step here would be to divide by negative 1 on both sides, and x would equal negative 8. If you didn't like that first equation and you wanted to use the other equation, here's the process for the other equation. The other equation was 3y plus x equals 19. If I substitute in a 9 for the y, I'm going to be multiplying 3 with 9. So 3 times 9 plus x equals 19. Simplify. 3 times 9 is 27. So 27 plus x equals 19. My one last step I would need to do is move 27 over to the other side and solve for x. The only way you can move it is by subtracting on both sides. When you subtract on the left, it goes away. So x is going to equal negative 8. Either way, you get negative 8. It's going to be your preference on which equation to choose. So lastly, you go back and you identify your solution. Your solution is going to be negative 8, 9, x, y. If you need more time, pause the video. I'm going to go ahead and move on to another example. In our next example, we're going to have coefficients other than 1 on your variables. So let's look at that. All right. Our next example, we're going to be looking at negative 10x plus 5y equals 25 and 10x minus 2y equals a negative 16. So don't get confused. This is a negative in front of the 16. So again, rewrite both of the equations so that you can just look at them and identify which equation or which variable you can cancel out here. So without looking at that plus sign, I'm going to look at these two equations and I'm going to look at the coefficients of the coefficients of x. So I have a negative 10 and I have a positive 10. I want to recognize if I take negative 10 plus a positive 10, it's going to cancel out. My y variables would not cancel out if I combine them. So with using that plus sign on the outside, you want to recognize that the elimination method would be helpful here because my x's will cancel out. When your x's cancel out, all you need to do is combine your y's and combine your constants. So here I'm going to take 5y adding a negative 2y. That's the same thing as 5 minus 2. 5 minus 2 is going to be 3y. And then if I take 25 and add negative 16, it's the same thing as taking 25 minus 16. That's 9. My last step here is to divide by positive 3 on both sides, so y will equal 3. Again, you're not done. That's just one part of your answer. So our next step is to go ahead and take your y value, and we're going to plug this in to find the x. And here I don't plug it into both equations. I'm just going to choose one. It doesn't matter which one. You can choose the first equation, you can choose the second equation. You're just plugging in y for one of the equations. So over here off to the right, I'm going to show the work. You're going to plug in 3 for y, and so I chose 10x minus 2y equals negative 16. If I'm plugging in a y, or 3 for y, I need to use parentheses. I can't do anything with 10x, so I'm going to bring it straight down. So 10x minus 2, instead of y, I substitute in 3, equals negative 16. From here, I need to simplify, get rid of the parentheses. I'm multiplying negative 2 with 3, so bring down your 10x. Minus 6 equals negative 16. Negative 2 times 3 is negative 6. My next step here is to solve for x. This is a two-step problem. I need to move the negative 6 over to the right side by using the opposite sign. I'm going to add 6 to each side. When I add 6 to each side, cancels out on the left. I'm going to bring down what I have left over. 10x equals negative 10. Last step here is to get rid of the 10 in front of the x. So I'm going to divide by 10 on both sides. 10 divided by 10 is my 1x equals negative 10 divided by a positive 10 is a negative 1. So now that you found your x and your y value, you're able to identify the solution as negative 1, 3. I'm going to go ahead and move on to the next example. If you need more time, you can pause the video or rewind and watch this again. And the last piece I'm going to go over are your special cases. Your special cases are where your variables cancel out and you are left with a true or a false statement. So you want to identify this either as infinitely many solutions or no solution. So here's the next example. The next example, again, you want to take the two equations and you want to simplify them, or you want to rewrite them. So I'm going to go ahead and cover up my solution over here. And give me one. Oh, well, you just saw it. Okay. So when you rewrite both of the equations, you're going to get 3x plus 3y equals 6 and negative 3x minus 3y equals 5. So when you look at the two equations, you can probably automatically identify that your x variables are going to cancel and your y variables are going to cancel. When things cancel out, they're basically 0, right? So 3x minus 3x is 0 and 3y minus 3y is 0. On the right side, however, 6 plus 5, I'm going to get 11. So when I look at this equation and my both variables cancel out using elimination, 0 equals 11 is not a true statement. When you get a false statement, we're going to identify this as no solution. Your variables cancel out. It's a false statement. your solution is no solution. That means these two lines never intersect. They have the exact same slope. And you can solve for y, graph them in your calculator, and take a look to visually see this. So now we're going to go ahead and go on to the next example. In the next example, you have 6x minus 6 and 6x minus 12y equals negative 6, and 6x plus 12y equals positive 6. So, again, rewrite both of the equations. And when you look at this and you add them together, your x's, negative 6x, positive 6x, are going to cancel out. Negative 12y, positive 12y are going to cancel out. So you don't want to just say cancel everything here. Or you do want to say cancel everything, but you want to recognize canceling as a value as well. So when I cancel everything on the left side, it is 0. On the right side, if I combine my negative 6 with my positive 6, I'm going to get 0 as well. 0 equals 0. Is that a true or a false statement? Well, 0 does equal itself, so it is a true statement. When you get a true statement and all the variables cancel out, we're going to say that this is infinitely many solutions. When it's infinitely many solutions, the two lines are overlapping. They're exactly the same line, same slope, same y-intercept. So your solution is infinitely many solutions. I'm going to go ahead and let you practice, and if you need more help, please contact your teacher or utilize the homework help online in your student portal.